Look up into the night sky. With a telescope, you might glimpse a jewel Saturn wrapped in spectacular rings. Saturn is a gas giant, a colossal ball of hydrogen and helium, spinning in the cold expanse of our solar system. For centuries its beauty has mesmerized us, symbolizing the vast, unexplored universe. Saturn is not alone. It commands a grand cosmic family of over 100 moons, each a world of its own. Some moons are tiny, mere captured asteroids. Others are larger than planets, made of ice, rock, and possibly liquid water. These moons aren't just points of light. They're destinations, holding secrets that could change our understanding of life and the cosmos. Imagine a system with so many different worlds, all orbiting a single, magnificent planet, a miniature solar system, a laboratory for understanding how planets and moons form and evolve. Each moon tells a different story, some scarred by ancient impacts, others hinting at ongoing geological activity. Exploring these moons is like opening a book with 100 chapters, each more fascinating than the last. The cosmic dance of Saturn's moons sparks our imagination and curiosity, the same drive that once sent humans across oceans and up mountains. Now, our oceans are made of space, and the mountains are entire worlds. Saturn and its moons represent the next great frontier for human exploration. They are a distant shore, waiting for our arrival. They challenge us to dream bigger, to reach further. The adventure that began when we first looked up at the stars continues. Saturn's system is a call to explore, to discover, and to expand our place in the universe. The journey is daunting, but the rewards are beyond imagination. What wonders await us among Saturn's rings and moons? Among Saturn's many moons, Titan stands out, a true giant, larger than Mercury. Titan's thick, nitrogen-rich atmosphere is unique among moons, shrouding a landscape both alien and strangely familiar. Here it rains liquid methane, and vast lakes and seas of hydrocarbons dot the surface. Mountains of water ice rise beneath orange clouds, and rivers carve through frozen terrain. Titan is a cold, dark version of Earth, where the chemistry of life might be stirring. Then there's Rhea, Saturn's second-largest moon. An ancient, icy world covered in craters, reflecting the violence of the solar system's past. Rhea's surface is bright and scarred, with mysterious wispy streaks, likely ice cliffs formed by tectonic fractures. Though once suspected to have its own rings, Rhea remains a stark, beautiful world of ice and shadow. Even the seemingly simple moons of Saturn have complex histories and hidden features. Titan and Rhea remind us that every moon is a world with its own story. They are keys to understanding Saturn's system, and perhaps the origins of life itself. These moons are not just objects of study, they are invitations to explore. What secrets do they hold beneath their icy surfaces? Now, let's journey to Enceladus, a small, brilliant white moon with a secret. Cassini revealed plumes of water vapor and ice erupting from its south pole, feeding Saturn's E-ring. These geysers point to a global ocean beneath Enceladus's icy shell, kept liquid by tidal heating from Saturn's gravity. This ocean is not just a pocket of water, it's a vast, salty sea, sloshing around a rocky core. Cassini's flybys found water, salts, silica, and complex organic molecules in the plumes, the building blocks of life. The presence of hydrothermal activity suggests energy sources similar to those that support life in Earth's deep oceans. Enceladus has everything we look for: liquid water, energy, and organic chemistry. It's one of the most promising places in the solar system to search for extraterrestrial life. The idea that life could exist in its dark ocean drives our desire to return. Enceladus is not just a moon, it's a beacon of hope. Its hidden ocean may hold answers to one of humanity's oldest questions. Are we alone? The search for life here is a powerful motivator for future exploration. Enceladus invites us to look deeper, to seek the unknown beneath the ice. Beyond the giants, Saturn's system is home to other fascinating icy moons. Mimaz, with its enormous Herschel crater, resembles the Death Star, a testament to the solar system's violent past. Its gravity shapes Saturn's rings, creating the Cassini division and shepherding ice particles across thousands of kilometers. Tethys features the ancient Odysseus crater and the immense Ithaca Chasma canyon, likely formed as its interior froze and expanded. Dion's surface tells two stories, one side bright and cratered, the other marked by bright ice cliffs and canyons from ancient tectonic activity. These moons, though smaller, play vital roles in Saturn's cosmic ballet. Each is a record of geological drama and cosmic history. Even the smallest moons influence the rings and each other, shaping the system's evolution. Their surfaces are archives of impacts, fractures, and ancient activity. Saturn's lesser-known moons remind us that every world, no matter how small, has a story worth exploring. Our knowledge of Saturn's moons comes from bold exploration, robotic emissaries sent across the void. Pioneer 11 and the Voyager probes transformed distant dots into worlds, revealing craters, valleys, and icy landscapes. The Cassini-Huygens mission revolutionized our understanding, orbiting Saturn for 13 years and making hundreds of close flybys. Cassini's powerful instruments mapped Titan's surface, revealed Enceladus's plumes, and explored the canyons and cliffs of Tethys and Dione. The Huygens probe made a historic descent to Titan's surface, giving us our only direct view from an outer solar system world. These missions provided the data, images, and discoveries that fuel our imagination. We now know Titan has the building blocks for life, and Enceladus hides a warm, salty ocean. The legacy of Voyager and Cassini is a treasure trove of knowledge, a foundation for the next chapter of exploration. The maps, chemical analyses, and stunning images inspire us to dream bigger. The next step, sending humans to see these wonders with their own eyes. Robotic exploration has shown us what's possible. Now, it's time to imagine what comes next. Why do Saturn's distant moons capture our imagination? They represent the possibility of a new beginning for humanity. For all our history, we've been bound to Earth, but the story of life is one of expansion and adaptation. The moons of Saturn offer a chance to become a multi-world civilization, securing our future and pushing our limits. The adventure itself is a powerful lure. Living beneath Saturn's rings would be an experience beyond compare. The search for life on Enceladus or Titan could answer the age-old question: are we alone? These moons are more than geological curiosities. They're locations of immense scientific and philosophical importance. The dream of settling Saturn's moons is about hope, curiosity, and the relentless desire to explore. They remind us that our journey in the universe has only just begun. Imagine living on Titan, not on the frigid surface, but in floating habitats drifting through its dense orange atmosphere. Titan's thick air and low gravity could allow humans to fly with wings, while cities float like airships above the methane lakes. Inside, life would be carefully managed, pressurized, warm, and filled with views of alien skies and landscapes. Robotic drones would explore the surface, while scientists study the chemistry and geology of this strange world. Community would be everything, pioneers sharing meals, growing food, and facing challenges together. Every day would blend high technology with natural wonder. These colonists would be the pioneers of a new branch of humanity, living on the edge of possibility. With Saturn's rings overhead, they'd be reminded daily of the adventure they've embraced. To build a home on a Saturnian moon, we must live off the land, using in-situ resources. Water is everywhere, locked in the icy crusts of moons like Enceladus, Rhea, and Titan. Robotic miners could extract and melt this ice, providing water for drinking, crops, and splitting into hydrogen and oxygen. Hydrogen becomes rocket fuel, oxygen, the air we breathe. On Titan, the nitrogen-rich atmosphere could be filtered and mixed with oxygen for a breathable environment. Energy is a challenge. Solar power is weak this far from the sun. Nuclear reactors would provide reliable electricity for mining, life support, and heat. With water for air, ice for fuel, and nuclear power for energy, a self-sustaining colony is possible. Every resource must be recycled and managed with care. Living on Saturn's moons would be an engineering triumph and a testament to human ingenuity. Our journey to the stars is more than technology. It's the story of who we are. We are explorers, driven to see what lies beyond the next horizon. The moons of Saturn are our new frontier, calling for our ingenuity and courage. Settling these worlds will change us, forcing adaptation and innovation. Looking back at Earth from Saturn's rings would be a profound, unifying experience. The path will be long and difficult, but the dream is too powerful to ignore. The possibility of life on Enceladus or cities in Titan's clouds is a goal worthy of our greatest efforts. These worlds can unite humanity with a shared purpose. When you look up at Saturn, see not just distant moons, but future destinations. The cosmos invites us onward. Saturn's moons may be our next great step into the universe. Join me on a journey far from Earth, past Mars and the asteroid belt, to Saturn, the jewel of our solar system. Saturn's rings are a breathtaking system, unique in our solar system. Made of countless pieces of ice and rock, they form a shimmering disk. From afar, the rings appear as a glowing halo stretching across space. Moons carve gaps in waves, creating a cosmic dance of ice and gravity. Imagine living near Saturn, looking up to see a brilliant band of light arching across the sky. Saturn, with its majestic rings and many moons, calls to us. The journey to Saturn is about wonder and discovery. The universe is full of places waiting to be explored. The adventure begins with a single question. What will we find when we answer Saturn's call? Why choose Saturn, so far from Earth? The answer is simple: knowledge, resources, and curiosity. Saturn and its moons are a scientific treasure chest, holding clues to our solar system's birth. With over 80 moons, each is a unique world. Titan has a thick atmosphere and lakes of liquid methane. Enceladus shoots plumes from a hidden ocean, maybe even a place for life. Saturn's rings are a vast reservoir of water ice, a vital resource for any space settlement. But there's a bigger reason: survival. Earth faces threats, and spreading out is insurance for our future. A settlement around Saturn would be a bold step toward becoming a multiplanetary species. Saturn challenges us to dream beyond our home planet. This is why we go. The adventure is just beginning. Living near Saturn is no easy feat. The challenges are immense. First, the cold Saturn is 10 times farther from the Sun than Earth, with temperatures near -180 degrees Celsius. Habitats must be expertly insulated and heated to keep people alive. Then, radiation. Saturn's powerful magnetic field creates intense radiation belts, deadly to humans. Habitats need thick shielding and must be placed outside the most dangerous zones. Distance is another obstacle. Saturn is over 1 billion kilometers from Earth. Even our fastest rockets take years to get there, and messages take over an hour each way. Settlers would be isolated, relying on their own skills and resources. Gravity is also a problem. Space habitats would be in microgravity, which weakens bones and muscles over time. To counter this, habitats must spin to create artificial gravity, allowing people to live and work more normally. Every aspect of life, food, water, health, must be carefully managed. The environment is unforgiving, but not impossible. With the right technology and determination, we can adapt. The harshness of Saturn's realm is a test of our ingenuity. It forces us to innovate, to build smarter and stronger. The challenges are real, but so is our resolve. Saturn's dangers are matched only by its potential. For those willing to face the unknown, a new world awaits. The path is difficult, but the rewards are extraordinary. Saturn's harshness is not a barrier, it's an invitation to rise to the challenge. We can't build on Saturn itself, so our homes must orbit the planet. Imagine vast space stations, rotating wheels or cylinders, creating artificial gravity for healthy living. These habitats, like Stanford Torrey or O'Neill cylinders, would be built from strong materials to hold air and shield against radiation. Water, mined from Saturn's rings, could form a protective layer around living areas, blocking radiation and supplying the community. The best orbits avoid the worst radiation, perhaps in gaps within the rings or around safer moons like Mimas or Tethys. Some habitats could even be built inside hollowed-out moons or asteroids, using rock for natural shielding. Building such structures is a massive task. We wouldn't launch everything from Earth. Instead, robotic factories and drones would mine local materials and 3D print habitat parts in space. Humans would arrive only after the basics are ready and safe. This approach using local resources is called in situ resource utilization, and it's key to sustainable space living. Every habitat would be a marvel of engineering, designed for comfort, safety, and efficiency. The void around Saturn would become home to vibrant, self-sustaining communities. These floating cities would be humanity's outposts in the outer solar system. The dream of living among the rings would become reality, one habitat at a time. Saturn's orbit would transform from emptiness to opportunity. The future of space settlement starts here. Powering a habitat near Saturn is a major challenge. The sun is distant and dim, Solar panels would need to be enormous to generate enough energy. The real solution is nuclear power. Nuclear fission reactors, already used in submarines and space probes, can provide steady electricity for years. Radioisotope thermoelectric generators, nuclear batteries, have powered missions like Cassini and Voyager. The ultimate goal is nuclear fusion, the process that powers the sun. Fusion reactors could use deuterium from Saturn's water-rich rings, offering nearly limitless clean energy. Until then, a mix of nuclear and solar power will keep habitats running. Every system must be energy efficient, recycling heat, minimizing waste, and making the most of every watt. Careful energy management is vital for survival so far from the sun. The right power systems make life possible in the cold darkness of Saturn's realm. With innovation, we can thrive even at the edge of the solar system. Energy is the lifeblood of any settlement, and Saturn's future depends on it. The challenge is great, but so is our capacity to solve it. Food and water are essential for life and must be produced locally. Hydroponics and aeroponics let us grow crops without soil, using nutrient-rich water or mist. Multi-level gardens inside habitats lit by powerful LEDs provide fresh grains, vegetables, and fruits. These green spaces also generate oxygen, acting as the habitat's lungs. Water is mined from Saturn's rings, melted, purified, and recycled endlessly. Every drop is precious. Waste is not an option. Protein comes from soybeans, lentils, fish tanks, and even lab-grown meat. Aquaculture and cultured meat offer efficient, sustainable protein sources. Closed-loop systems ensure nothing is wasted. Air, water, and nutrients are all recycled. The result: a balanced, self-sustaining food system. Saturnian settlers become cosmic farmers, growing everything they need. The ability to produce food and water is the foundation of any successful colony. With the right technology, even the void of space can become fertile ground. Survival depends on turning Saturn's resources into life. Before humans, robots lead the way. Missions like Cassini-Huygens have mapped Saturn, studied its rings, and revealed hidden oceans on moons like Enceladus. These robotic explorers teach us where to build, what to avoid, and how to survive. The International Space Station is our training ground, showing us how to live and work in space for years at a time. On the ISS, we learn to recycle air and water, counteract microgravity, and handle emergencies. Every lesson from these missions prepares us for Saturn. Robots scout, build, and test before humans arrive. Their discoveries shape our plans and make future settlements safer. The knowledge gained from decades of robotic and human missions is our greatest asset. We stand on the shoulders of these pioneers. Their work lights the path to Saturn. The future of exploration is built on their legacy. Imagine waking up in a Saturn habitat, gazing out at the planet's rings, a luminous arc across the darkness. Your day is structured, tending crops, maintaining systems, piloting mining ships, or conducting research. Everyone has a role, working together to keep the community thriving. After work, you exercise in the gym, stroll through a park under a simulated sky, or relax with friends. Recreation and community are vital. Sports, movies, and shared meals bring people together. Communication with Earth is slow, but bonds with fellow settlers are strong. In the evening, you gather at an observation deck, watching Saturn's moons and the ever-changing rings. Awe and wonder are part of daily life, but so is a sense of belonging. This strange, beautiful place becomes home. You are a Saturnian, living a dream once thought impossible. Life here is challenging but filled with purpose and discovery. The rings are not just scenery. They're a symbol of your new world. Every day beneath the rings is a step into humanity's future. Living around Saturn may seem like science fiction, but history shows we turn dreams into reality. Crossing oceans, flying, landing on the moon, each was once impossible. The journey to Saturn is the next step in our cosmic adventure. Building a home there would transform humanity, proving we're not bound to one planet. Saturn's settlers would be pioneers, creating a new society in deep space. Their children would grow up with the rings as their sky, Earth a distant memory. This future will take generations, new rockets, life support, and international cooperation. The goal is worth the effort, a united, thriving human presence beyond Earth. Saturn is more than a planet, it's a symbol of our potential. When you look up at the night sky, remember, Saturn is a destination, a promise, a future home. The path is long, but we are destined to walk it. We are explorers, born from stardust, reaching for the cosmos. The rings of Saturn are waiting. Will you be among those who answer the call? When we look at Saturn, we see more than a planet. We see a realm of over 100 moons, each a world of its own, orbiting in a mesmerizing cosmic dance. Saturn's gravitational pull has gathered a family of satellites, each with its own story to tell. Some are tiny and lumpy, shaped by countless collisions, while others are massive, with atmospheres and weather systems that rival planets. These moons aren't just dead rocks, they're dynamic, fascinating places, with shifting surfaces and mysterious activity beneath their icy crusts. Mimas looks like the Death Star, its giant crater a reminder of ancient impacts that shaped the solar system. Iapetus is half bright, half dark, its surface split dramatically as if painted by the universe itself. And then there are the giants, Titan and Enceladus, moons that have captured the imagination of scientists and dreamers alike. Titan, larger than Mercury, is shrouded in orange haze, hiding rivers and lakes of liquid methane beneath its thick clouds. Enceladus, brilliant white, shoots plumes of water vapor from a hidden ocean, hinting at the possibility of life beneath its frozen shell. These moons challenge our ideas of where life could exist, pushing the boundaries of what we thought possible in the cold reaches of space. Studying them reveals clues about how our solar system formed and how worlds evolve over billions of years. Their icy surfaces are like time capsules, preserving the story of our cosmic neighborhood and holding secrets from the earliest days of the solar system. The Cassini-Huygens mission transformed our understanding, flying through Enceladus's plumes and landing on Titan, sending back data that changed the way we see these distant worlds. Today we build on that legacy, planning new missions and dreaming of human explorers who might one day walk these alien landscapes. Saturn's moons are not just distant points of light, they're keys to our past and perhaps our future, holding answers to questions we've only begun to ask. Each discovery brings us closer to understanding our place in the cosmos and inspires us to keep searching for what lies beyond. The adventure is just beginning, as new generations of explorers prepare to answer the call of these icy worlds. These worlds are waiting for us to explore, to unlock their mysteries, and perhaps even find signs of life. The next chapter in their story, and ours, is about to unfold as we reach farther than ever before. The icy moons of Saturn are calling. Will we answer their invitation to explore the unknown? Titan is Saturn's largest moon, a mysterious world that has fascinated astronomers for decades. It's one of the most intriguing places in the solar system, standing out even among Saturn's many moons. Titan is shrouded in a thick orange atmosphere, so dense that sunlight barely reaches the surface. Here, rivers, lakes, and even vast seas exist, but instead of water, they're filled with liquid methane and ethane, creating an alien hydrological cycle. The mountains that rise from Titan's surface are made of rock-hard water ice, sculpted by the frigid temperatures and the moon's unique weather. If you could stand on Titan, you'd see a perpetual hazy orange sky above you and feel an atmospheric pressure higher than Earth's, enough to make you feel slightly compressed, but not crushed. In 2005, the Huygens probe became the first spacecraft to land here, sending back images of a surface littered with icy pebbles and channels carved by flowing methane, hinting at a dynamic and changing landscape. Titan's methane cycle is eerily similar to Earth's water cycle. Methane evaporates, forms clouds, and rains down, shaping river channels and filling lakes, constantly reshaping the moon's surface. It's the only other place in the solar system with stable surface liquids, making it a rare and valuable target for exploration. The ground is coated in tholins, complex organic molecules, formed by sunlight interacting with Titan's atmosphere. These are considered the building blocks of life, and they blanket the surface in a rich, orange layer. While the surface is far too cold for life as we know it, scientists believe there may be a vast, hidden ocean of liquid water beneath Titan's icy crust, kept warm by tidal forces from Saturn. If organic material from the surface somehow mixes with this subsurface ocean, it could create a chemical soup teeming with the potential for life's chemistry to begin. Titan is a natural laboratory for studying prebiotic chemistry, offering scientists a glimpse into the processes that might have sparked life on early Earth. It's a place where the ingredients for life are not just present, but abundant. waiting for the right conditions or spark to set something extraordinary in motion. Exploring Titan could reveal not only how life begins, but also how it might arise in environments vastly different from our own, expanding our understanding of what's possible. It's a world that is both alien and strangely familiar, echoing Earth's landscapes in a frozen, orange-tinted mirror. Titan challenges our understanding of what makes a world habitable, pushing the boundaries of science and imagination. And it may hold secrets about life's origins, waiting to be uncovered by future explorers and scientists. Enceladus, though small, is a world of astonishing secrets and cosmic intrigue. It's one of the most promising places in our solar system to search for life beyond Earth, capturing the imagination of scientists and dreamers alike. Its surface is a dazzling shell of brightwater ice, concealing a vast global ocean beneath that remains hidden from view. At the South Pole, dramatic tiger stripes fracture the ice, and from these mysterious cracks, plumes of water vapor and ice particles erupt into the vacuum of space. The Cassini spacecraft daringly flew through these plumes, detecting water, salt, silica, and even organic molecules, key ingredients for life as we know it. The presence of silica hints at hydrothermal vents on the ocean floor, just like those found deep in Earth's oceans, where life thrives without sunlight, fueled by chemical energy. All the essential ingredients for life are here, waiting to be discovered and understood. There is liquid water, a source of energy and complex organic chemistry, everything needed for life to potentially arise. Deep beneath its frozen crust, Enceladus could host living ecosystems in its dark, alien ocean teeming with unknown possibilities. If life exists there, it would be a profound discovery, showing that biology can emerge wherever the right conditions are met, even in the most unexpected places. Enceladus is a window into the possibility of life beyond Earth, a beacon for future exploration and hope. Its spectacular plumes offer a direct sample of a hidden ocean, making it uniquely accessible for scientific study. The search for life here is just beginning, with each discovery bringing us closer to answering age-old questions. This tiny icy moon could one day answer one of humanity's biggest questions: are we truly alone in the universe? The plumes of Enceladus are a form of cryovolcanism, ice volcanoes erupting water, not lava. This process brings material from the hidden ocean straight into space, giving us a free sample. Future spacecraft could fly through these plumes, analyzing organic molecules for signs of life. Cassini found simple and complex organics, the building blocks of proteins and DNA. The energy from hydrothermal vents could drive the chemistry needed for life. Cryovolcanism isn't unique to Enceladus. Other icy moons may have it too. Wherever there's ice, heat, and water, the potential for life exists. These moons are no longer seen as dead worlds, but as dynamic places where life could emerge. The search for life's building blocks continues. Each plume is a message from a hidden ocean. Will we find life's signature in the spray? If humans ever visit these moons, survival will demand innovation. The cold is deadly. Habitats must be insulated and shielded, likely built underground or within the ice. On Titan, the thick atmosphere offers some protection, but we'd still need enclosed bases for warmth and air. Subterranean habitats could be carved into the ice, creating safe, warm spaces. On Titan's surface, bases might rise near methane seas, launching submarines to explore alien depths. Low gravity would make construction easier, but life would depend on reliable technology. Air, water, and food would be recycled in closed loops. The psychological challenge of isolation would be immense, yet the reward, exploring new worlds firsthand, would be worth it. These habitats would be pockets of life in a frozen wilderness. The dream of living on Saturn's moons is within reach. The next explorers may call these icy worlds home. Powering a base on Saturn's moons is a major challenge. Sunlight is too weak for solar panels. Robotic missions use radioisotope thermoelectric generators, or RTGs, nuclear batteries that last for decades. Human outposts would need small nuclear reactors, buried deep in the ice for safety and efficiency. Waste heat could help melt ice for construction, or keep equipment warm. On Titan, wind turbines or hydroelectric generators in methane rivers could supplement power. Adapting our technology to these alien environments is key. A mix of nuclear and renewable energy would create a resilient grid, Every watt of power would be precious in the outer darkness. Energy is the lifeblood of any off-world settlement. Harnessing it will be our first step toward survival. The future of exploration depends on it. Even with human bases, robots will lead the way across these dangerous frozen worlds. On Titan, rugged rovers and autonomous submarines will explore dunes, riverbeds, and methane seas. These machines will sample ice, analyze organics, and map alien landscapes. On Enceladus, drones, cryobots, will fly into plumes, capturing samples for analysis. Ice moles will tunnel through the shell, seeking the hidden ocean below. Each robot extends our reach, venturing where humans can't yet go. The first probe to touch Enceladus's ocean could make history. Robots are our eyes and hands on these distant worlds. Their discoveries will pave the way for human explorers. The age of robotic exploration is just beginning. The ultimate goal is to answer, are we alone? Enceladus offers a chance to find life as we know it, microbes thriving in a dark ocean. Titan tempts us with the possibility of life as we don't know it, based on methane, not water. Discovering even simple life would transform our understanding of biology and our place in the universe. Titan's chemistry may echo Earth's distant past, offering clues to life's origins. Every sample, every analysis brings us closer to the answer. These moons are natural laboratories for studying habitability. By exploring them, we learn about the potential for life across the cosmos. Each discovery adds a piece to the puzzle. The search is far from over. Saturn's moons may hold the key to life beyond Earth. Exploring Saturn's moons is more than science, it's a testament to human curiosity and unity. These worlds are the next frontier, pushing us to innovate and cooperate. The technologies we develop will benefit life on Earth, from recycling to energy. Grand missions unite nations and inspire generations. The discoveries we make will belong to all humanity. Finding life elsewhere would forever change our perspective. We'd see ourselves as part of a vast, living cosmos. The journey is challenging, but the rewards are profound. Saturn's moons are calling us to explore, to learn, and to dream. It's a journey we must make. The universe is vast, far beyond our imagination. Each star in the night sky is a sun, possibly with its own planets. Our sun is just one of billions in the Milky Way, and there are billions of galaxies beyond. We live on a small blue world, a speck in the cosmic ocean. For most of history, humanity has gazed at the stars, wondering what lies beyond. Curiosity has always driven us forward. Our journey began with telescopes, then probes, and finally, footsteps on the moon. Each discovery revealed more beauty and complexity. We learned about planets, stars, nebulae, and black holes. The universe is a story, and we're just beginning to read its first pages. Now we stand at a new threshold, ready to leave our cosmic shoreline and sail into the ocean of space. Our solar system is our neighborhood, filled with wonders. We've visited Mars and Venus, sent robotic eyes to Jupiter and Saturn. These missions revealed strange, beautiful worlds, places we might one day call home. The dream is no longer just to visit, but to stay, to build new homes for humanity among the stars. This is not just science fiction, it's a possible future. A future where humans are a multiplanetary species, where our children might be born on another world. The journey will be difficult, testing our technology and spirit, but to explore is to be human. The cosmos awaits. Our journey is just beginning. We are ready to take the next leap. The universe calls us onward, and we are listening. Saturn, the ringed jewel of our solar system, is surrounded by over 80 moons, each a world of its own. These moons are not barren rocks, but diverse and fascinating places. Some have atmospheres, hidden oceans, or erupt with icy volcanoes. Titan and Enceladus stand out. Titan is larger than Mercury, with rivers and lakes of liquid methane. Enceladus hides a vast ocean beneath its icy crust, erupting plumes into space. These moons may hold the ingredients for life, and the future of human exploration. The adventure is just beginning. Will we answer the call? Imagine a world shrouded in orange haze where it rains liquid natural gas. This is Titan. Titan's thick atmosphere, mostly nitrogen, shields its surface from radiation. It's the only moon with a dense atmosphere, but it's bitterly cold, minus 179 degrees Celsius. Here, methane and ethane form rivers, lakes, and seas, creating a hydrocarbon cycle. Vast seas like Kraken Mare dwarf Earth's Great Lakes. Submarines could explore their depths, we could sail on alien waves. The landscape is sculpted by wind and rain, with dunes of solid hydrocarbons and mountains of water ice. Building a city on Titan would be a monumental challenge, but possible. Habitats would need insulation and their own heat and light. Nuclear or fusion power could provide energy. The thick atmosphere protects from radiation, so only warm suits and breathing masks are needed outside. Life on Titan would be a life of exploration and adaptation. Abundant hydrocarbons could fuel rockets and vehicles. Water ice could be mined for drinking, farming, and oxygen. Hydrogen from water and nitrogen from the air could make fertilizer. Titan offers many raw materials for a self-sustaining outpost. The challenges are immense, but so are the possibilities. Titan could be humanity's first true home beyond Earth. A city here would be a testament to our ingenuity. The dream of living on another world is within reach. Titan is waiting for us to arrive. The next frontier is closer than we think. Will we take the leap? Enceladus, a small, icy moon, hides a world of activity beneath its frozen surface. A global ocean of liquid water lies below, kept warm by Saturn's gravitational pull. Geysers erupt from cracks near the South Pole, shooting water vapor and organic molecules into space. Cassini flew through these plumes, finding the building blocks of life. Silica in the plumes hints at hydrothermal vents on the ocean floor. On Earth, such vents teem with life. A city on Enceladus would be built beneath the ice, protected from radiation and vacuum. Robotic drills could melt tunnels and chambers, creating a sanctuary lit by artificial sunlight. Life here would focus on science and discovery, exploring the hidden ocean with robotic submarines. These subs would map the ocean floor, study vents, and search for life. Living on Enceladus would be like a deep-sea research station, but on a cosmic scale. The discoveries could change our understanding of life in the universe. This city would be dedicated to answering. Are we alone? The quest for life drives us to the farthest reaches. Enceladus is a gateway to the unknown. The answers may be waiting beneath the ice. Our search continues. The universe holds its breath. Building cities on Saturn's moons demands new technologies and bold thinking. Earth-based construction won't work in such extreme environments. We must innovate and use local resources. This is in situ resource utilization. On Titan, abundant hydrocarbons can be turned into plastics and building materials with 3D printers. Water ice can be mined for construction and life support. On Enceladus, water ice is the main resource, used for habitats, air, and fuel. Energy is vital. Solar power is weak this far from the sun. Advanced nuclear reactors and eventually fusion could provide reliable power. Fusion could use hydrogen from local water ice, making cities energy independent. Habitats must be more than shelters. They must be ecosystems. Closed-loop life support will recycle air, water, and waste. Plants grown in hydroponic farms will provide food and oxygen. These systems are essential for survival and self-sufficiency. Our cities will become living organisms, self-sustaining outposts in the cosmos. The architecture of space is about adaptation and resilience. The future will be built from the materials of new worlds. What would daily life be like on a moon of Saturn? Your morning begins with artificial dawn, not sunrise. Outside, you see Titan's orange haze or Enceladus's icy ceiling. Saturn's rings stretch across the sky, a constant, breathtaking reminder of where you are. Work, learning, and community fill your day. Children study both Earth's history and the science of their new home. Transportation is through tunnels or electric vehicles. On Titan, you might fly in the thick atmosphere. Art, music, and sports evolve in low gravity, inspired by alien landscapes. Community is everything. Everyone has a role, and connection to Earth is maintained by high-speed communications. Life here is a blend of the familiar and the fantastically new. The journey to Saturn's moons is filled with challenges, guardians at the gate of our future. Radiation is a major threat. Saturn's belts and cosmic rays require serious protection. Titan's thick atmosphere shields us, but Enceladus demands habitats deep beneath the ice. Extreme cold tests our technology, habitats, vehicles, and suits must be perfectly insulated. Power failures could be deadly. Reliability is essential. Distance and isolation mean settlers must be self-sufficient, able to fix any problem. Psychological resilience is as important as physical health. Every system needs redundancy. Every person needs training. The mental and emotional well-being of settlers is crucial. We're not just sending bodies to space, we're sending minds and spirits. Overcoming these challenges will define our success. The guardians at the gate test our resolve. Only the bold will pass through. Cities on Saturn's moons would be scientific outposts, unlocking cosmic secrets. The search for life is the primary goal. Submarines could explore Enceladus's ocean for microbes. Finding life elsewhere would be a profound discovery, showing life is common in the cosmos. On Titan, we'd search for exotic life based on methane, testing the limits of biology. Discovering a second Genesis would revolutionize science. These cities would also be platforms for astronomy. Telescopes could peer into the universe with unprecedented clarity. We'd study Saturn's rings, atmosphere, and magnetic field, learning how planetary systems form. The knowledge gained would reshape our understanding of the solar system and life's potential. Science would be at the heart of these new worlds. The frontier is a laboratory for discovery. The universe is waiting to reveal its secrets. The dream of living on other worlds is as old as humanity. We are explorers by nature, and now the cosmos is our new ocean. Expanding beyond Earth is about survival and hope. Life on Earth is fragile. Becoming multiplanetary is our insurance policy. Cities on Titan and Enceladus would be beacons of hope, proof we can thrive beyond Earth. This future demands our best: science, engineering, art, and unity. The journey will transform us, making us wiser and more compassionate. The stars are not just distant lights, they are destinations. The universe invites us to explore and write a new chapter. Our journey is just beginning. The story of humanity will be written across the cosmos. Our descendants will look back at this moment as the dawn of a new era. We are ready to step off our cosmic shore. The stars await.